Welcome to my channel. In this video, we are going to discuss a deadlock, diagram of a process state, definition of deadlock, the deadlock problem and examples, deadlock condition, deadlock characterization. So content, just now I told, revise process state, it is admitted, ready, selected, running, completed, terminated. If there is a need of IO, it will change to wait state. If it is over, it will come back to ready. If there is an interrupt, move from run to ready. Now, try to recall long-term scheduler, short-term scheduler also. Let us go to the deadlock. Before we go on discussion about the deadlock in the operating system, already told in the previous video that lot of concepts what all we discuss in our operating system subject are applicable to day-to-day life. To understand the deadlock in the operating system, let us consider a general example. Let us take there is a highway or something, a big road is there. Because of bridge, say the size of width of the road is very small. Vehicles are moving, and let us consider these two vehicles are coming inside the bridge. Now when they come on the bridge, now they cannot continue moving. Now let us consider this as a vehicle 1, vehicle 2. Vehicle 1 is waiting for the vehicle 2 to go back. Vehicle 2 is waiting for the vehicle 1 to go back. Now they are waiting for each other. I said wait for each other, not made for each other. In day-to-day life also, we wait for each other. We fight with our classmate, roommate, etc. And we are interested to talk, but we expect let them start first. We wait for each other. When I say multi-programming, all of you know there are more than one program are active in the system. Many processes are there, but I have only few resources. States of the process, just now you have revised, ready, run, wait. What is the meaning of a deadlock? What is the definition? A set of blocked processes, each holding a resource and waiting to acquire a resource held by another process in the set. Very simple example for day-to-day life is when two trains approach each other, I can say deadlock has happened. Now we are going to describe methods that operating system can use to prevent or deal with the deadlock. So these concepts we can use for our day-to-day life also. No doubt we are also going to have a deadlock in our day-to-day life. Try to understand this definition. Even if you do not understand also, in the further slides we are going to discuss again. Try to understand deadlock. There are a set of processes P1, P2, P3, P4. These are blocked, all are in the waiting state and they are waiting for each other. Means P1 is requesting some resource held by P2. P2 is requesting some resource which is held by P4. P4 is requesting some resource held by P3. P3 is requesting some resource which is already held by P1. Like that something they are waiting for each other. So these set of processes will never change their state from wait state to ready. So we say this situation as a deadlock. The simplest example, let us consider two disk drives are there. I have two processes in the system, P1 and P2. Each is holding one disk drive and they are in need of another one. They are requesting but they are waiting for each other. For example, P1 is thinking that P2 will release, P2 is thinking that P1 will release, P1 is waiting for P2, P2 is waiting for P1, wait for each other. Those who are good in semaphore, they can understand. Now wait of A, it is waiting for a signal of A from the P1, and similarly now wait of B, So this, like this, if we wait, now P0 will wait for P1, P1 will wait for P0. So these will be in the infinite wait state. That situation we are going to call as a deadlock. We have discussed just now this bridge crossing example. What are the solutions, sir? Traffic, we can make it only in one direction, but it is difficult. Each section of a bridge can be viewed as a resource to understand the deadlock in our operating system also. If a deadlock occurs, it can be resolved if one car backs up, preempt the resource and roll back. Even in life also, when you fight each other, somebody should roll back. You cannot continue in the same state. Several cars may have to be backed up if deadlock occurs. Already these two have reached here, then only this car is coming backward. It's difficult. All cars should come back. Starvation is possible. Even in the life also, the same person has to roll back every time. Real-time deadlocks, day-to-day life you are observing in the roads in big cities. Because of this traffic, you find a traffic jam, which is very difficult to continue. Now, any car, all are in the deadlock state. You just read it, take a few seconds. Even in day-to-day life, somebody has written in the internet, just sharing with you. Thread 1 wants object 2. Thread 2 wants object 1. But object 1 is held by thread 1 or a process, you can say. And object 2 is already held by process 2. Now, process 1 or thread 1 is waiting for thread 2. Thread 2 is waiting for thread 1. They have become wait for each other. You can pause the video and just read it. There is a saying in our day-to-day life. You can't get the job without experience, and without experience you can't get a job. We say something like a deadlock. In Canada they say, huch bidalda madhi agudulla, madhi agaldu hattu huch bidudulla. It's difficult. So, system model. Resources we represent as R1, R2, R3, R4, something like that. Resource means CPU cycle, memory space, input-output devices, and each process resource type Ri. For example, I have a printer, Wi instances, means I may be having 2 instances, 2 printers I may be having. And remember, each process utilizes a resource as follows. It will request for a resource, it will use a resource, and it will release the resource. Summary what all we have discussed. We can pause it, go through. Deadlock is a set of blocked processes, each holding a resource and waiting for acquired to another resource held by another process which is in the same set. That's why we say wait for each other. When 2 trains approach each other, bridge crossing example, you can take a traffic jam. All these are a deadlock examples. Resource types R1, R2, R3. Instance means count how many you have. Each process utilizes a resource as follows. Request, use it, and once usage is over, release it. Deadlock characterization. Deadlock can arise if and only if 4 conditions hold simultaneously. First is a mutual exclusion. Only one process at a time can use a resource. Many resources are not shareable. For example, a printer cannot be shared by 2 processes. This should be true. And another is hold and wait. A process holding at least one resource is waiting to acquire additional resource held by another process. These are the 2 conditions. Other 2 conditions are no preemption. A resource cannot be released voluntarily by the process holding it after that process has completed. We have taken just now request, use it, release it. Forcibly that resource should not be taken by some other process. So no preemption. Forcibly we should not take a resource back from the process. This is another condition. Circular wait. There exists a set of P0, P1 set of processes waiting for a resource which is held by another process within this set. For example, P naught is waiting for a resource held by P1, P1 is waiting for a resource held by P2, P2 is waiting for a resource held by Pn, Pn is waiting for a resource held by P0. Like that, the circular wait is existing. So these are the four conditions. If all four conditions are true, then only the deadlock may occur. Conditions are mutual exclusion, hold and wait, no preemption, circular wait. And simplest example, 2-disk drive I told. You can see here, P1 and P2, they are holding one disk drive. They are requesting for another. They are holding, hold and wait is true. And disk drives, these are not shareable, mutual exclusion is true. No preemption. P1 should not snatch from the P2. P2 should not forcibly take from the P1. That is a no preemption. Circular wait is true. P1 is waiting for P2, P2 is waiting for P1, P1 is waiting for P2, circular wait is also true. All four conditions are true, hence deadlock occurs. And many times this deadlock condition will arise in our day-to-day life. A project mate, roommates, wife mate. Mate means I am sharing. I am sharing the life, I am sharing the room, I am sharing the project. Whenever sharing comes, remember problem comes automatically. It is for day-to-day life also. So try to avoid the deadlock. And summary, what all we have discussed so far. Diagram, process diagram, definition of the deadlock. It's like a wait for each other. So avoid it. The deadlock problem and examples, deadlock conditions, MHNC I told, characterization I told. Avoid deadlock in the day-to-day life. Not to become wait for each other, try to become made for each other. This is a reference book. Thank you for watching this video.